Welcome to Angles in Circles, covering theorems 11 and 12. This video is about two fairly straightforward theorems which use the idea that the angle at the center is twice the angle at the circumference. Theorem 11 simply states that the angles in the same segment are equal to each other. We have to make sure though that they are subtended by the same chord, or arc in this case, AB. Remember theorem 3, which tells us that the angle at the center is twice the angle at the circumference? I know you do. Well, if you construct another angle at the circumference that is subtended by the same arc, then it has to be equal to the other angle at the circumference, because it is also half the angle at the center. This is how we're going to prove it. Our aim is to prove that angle ADB is equal to angle ACB. We know that angle ADB and angle ACB are angles subtended by the same chord AB, with a center of O. We need to construct OA and OB, and I've done that in red to show you. We start our proof by stating that angle AOB is equal to two lots of angle ADB, and we know that because angles at the center are twice the angles at the circumference. Similarly, angle AOB is equal to two lots of angle ACB for the same reason. We can now say that angle ADB is equal to angle ACB because both are half of angle AOB at the center. Let's look at a couple of examples which use this theorem. Example 7 says, if angle CAD is 28 degrees and angle ACB is 44 degrees, calculate the size of angle AXD, giving reasons. The first thing you should do is mark in the angle they want you to find, and also take note that they don't ask you to prove anything, just to give reasons, so you don't have to set up an aim, a data, or a proof. Pause the video and take a minute to try this one out for yourself, giving reasons. We know angle XDA is 44 degrees because angles in the same segment are equal to each other. Therefore, angle AXD has to be 108 degrees because the angle sum of a triangle is 180. Done. Our second example is a long one. It says that A, B, and C are 3 points on the circumference of a circle, such that the chord AB is equal to the chord AC. P is any point on the circle such that A and P are on opposite sides of BC. We are asked to prove that angle APB is equal to angle APC. Take a minute to draw this example and try and work it out for yourself. Note that there is an isosceles triangle in there, and we just learnt that angles in the same segment are equal to each other. The question says to prove, so we start our answer with the aim of proving that angle APB is equal to angle APC. We know that AB equals AC, and P is any point on the circle such that A and P are on opposite sides of BC. Our proof now says that angle ABC equals angle ACB because base angles of an isosceles triangle are equal. We can now say that angle ABC equals angle APC because they are angles in the same segment. Similarly, we can say that angle ACB equals angle APB for the same reason. Therefore, angle APB equals angle APC as shown above. The next theorem uses the same property as theorem 11. Theorem 12 lets us know that the angle in a semicircle is a right angle. We want to prove that angle ABC is 90 degrees. We know that AC is a diameter and B is any point on the circumference, which makes the angle ABC. We start by saying that the angle AOC is two lots of the angle ABC, and because the angle at the center is twice the angle at the circumference. But we know that angle AOC is 180 degrees because it's a straight line. Therefore, angle ABC has to equal 90 degrees. Example 8 gives us some practice at using the theorem. It says that AC is the diameter of the circle with a center O. We know that angle ABD is 62 degrees and angle ACB is 54 degrees. Find the value of each pronumeral. Practice time. Try this one for yourself. I start my proof by saying that x and 62 degrees equal 90 because they are angles in a semicircle. Therefore, x equals 28 degrees. I can also say that y is 62 degrees because it is an angle in the same segment as angle ACD. Finally, I state that z plus 90 plus 54 is 180 degrees, and I can say that because the angle sum of a triangle ABC is 180. Therefore, z is 36 degrees. Next lesson we look at cyclic quadrilaterals and some of the theorems that are associated with them. Thanks for watching.